I think you guys understand real easy what multiples are. You know, okay, but factors, even some of my sixth graders are kind of like, the biggest problem is remembering all of them. So, like, factors, like all the numbers that can go evenly into 16. We know 1 can go in there. 1 goes into 16, look, 16 times. No, it's not in order yet, but that's okay. So 16, what's another number that can go into it, Taya?
2.
Now watch this, guys. If I say 2 can go into it, Taya, how many times can 2 go into 16?
8 times.
8 times. So now you know 2 and 8 can go into 16. Tanner?
Do you have to list every single number that goes into it?
Evenly, yes. Every number that goes into it evenly.
What if it's like 130?
There's a lot of factors. Okay, so what other number can go into 16 evenly? Tanner?
4.
There you go. How many times can it go in there?
2. Or 4 times.
Okay, do I need to put 4 again? No. Okay, so that's all of them. Now, as your teacher, and even in IXL, it's okay if they're not in order, but you want to try to rewrite them in order.
It's okay for both letters.
Yeah, least to greatest.
Will Excel count off if it's not in order?
IXL will not. But next year, you don't know who you have as a teacher, and they may. Okay, so now that we understand factors and multiples, we're going to go on to divisibility. And I'm going to give you, does it go into that in your book? Does it? No. Yes, it does. Okay, so turn to page, I'm going to put divisibility rules, page 137 in a star.
A lot of eyes in it.
Yep. So divisibility rules, page 137. And open your book to page 137.
I was on 139.
That's fine, but look at 137. All right, do y'all see the divisibility rules or tests?
Yes, ma'am.
Right there. Okay, y'all probably learned this last year, okay, because I literally just taught 6th grade. So these are the divisibility tests. I have an IXL link. If after we're done, y'all remind me, I'll make sure and check, because 6th grade's got it. And you can practice these. Now, let me ask you this. Can you get through math without knowing these?
Yeah.
Absolutely. These, I told 6th grade, they're like cheat sheets. If you can remember these, most of them, all of them, whatever, then it makes finding factors and dividing a lot easier, like prime factor trees and stuff like that. But if you, for whatever reason, cannot remember these, it's okay. All right, these are it's helpful. The 6th graders are starting to figure that out, but it doesn't mean you can. Some people with certain learning disabilities will not remember this. They can remember 2 times 2 is 4. They can remember math facts, but remembering these type of rules, it is just not going to happen. Okay, and that's okay. Okay, so what this is, it says, and again, y'all did this last year. A number is divisible by 2 if it ends in 0, 2, 4, 6, or 8. If it's even or ends in 0. A number is divisible by 3 if you add all the digits and it's divisible by 3. For example, I'm just writing this down.
Do we have to write this down?
No. Where are my notes? Lord, I literally just, are they in my hand? No. Oh, no. Yeah. There they are. Okay. So, like, for example, and you don't need to write this down unless you want to, okay? So, the rule of 3. I can write this down right here. the rule of 3, and I'm only going to write the ones I'm going to do like examples that are weird. The rule of 3 says to add all the digits, sorry, and divisible by 3. For example, 21. If we do 2 plus 1, what does that give us?
3.
Is 3 divisible by 3? Then 21 is divisible by 3.
What?
Okay, I'll give you another example. Let's say I have numbers 153. And I want to know, is 153 divisible by 3?
Can't you just divide?
No. Yeah, you can. Yeah. But watch this. Add the digits. 1 plus 5 plus 3. What do you get?
It's 9.
Is 9 divisible by 3?
Mm-hmm.
Then
So-
this is divisible by 3.
How does that work? So do we do that with every number?
You can choose any number you can check to see if it's divisible by 3 by adding the digits, and whatever you get, if that's divisible by 3, then it's divisible by 3.
How in the world does that work?
I don't know. Okay, guess what? The rule of 9.
Oh, I know this rule.
It's the same one.
I can do it with my hands.
No, watch. Add digits and divisible by 9. For example, the one we just did, 153. If we add the digits, 1 plus 5 plus 3, what do you get?
9.
Is 9 divisible by 9? Then 153 is divisible by 9. Ooh.
Do we do that with every number?
Yeah, add all the digits. Okay, here's another one. A little bit easier, obvious. 18. Let's pretend you don't know that 18 is divisible by 9. Add the digits. 1 plus 8, what do you get?
9.
Is 9 divisible by 9?
Yes.
Then 18 is divisible by 9. Okay?
Do you do it with 12 too? 3.
That would give you 3.
So everything by 3.
That would be if it's divisible by 3, but 1 plus 2 is 3, right? That's not divisible by 9.
Right, I mean, like, can 12 make, like the 9 place?
I don't know what you're saying.
I mean, can 12 be in place of 9?
No.
Okay.
Yes.
So if we have like a really big number, like in like the hundreds or thousands even, if we were to add all the digits together, we wouldn't be able to find all of their what are these called?
Factors?
Factors, because what if it's like 150, one of them is 50, but you wouldn't find that getting 6.
Okay, but that's the thing is then you can just go over and try dividing. But for example, if it's even, how many times does 2 go in there? Well, then that's a factor.
75 times. If it were 50.
Right. Okay. The rule for 6, and then we're going to move on. The rule for 6, a number is divisible by 6 if it's also divisible by 2 and 3. And like 5, if it ends in 0 and 5. 4 is weird and 8 is weird. So anyway, I gotta move on. I have an IXL that if you study this chart and do that IXL, it'll get easier.
So 6, it has to be both. So it can't just be like 2 or just be
Has to be divisible by 2 and 3. Then it's divisible by 6. Isn't that interesting?
3. Yeah.
Like, for example, 18. Is 18 divisible by 2? Yeah, because it's even, right? Well, what's 1 plus 8? So is it also divisible by 3?
Yes.
So then it is divisible by 6.
Cool.
Now, again, this is helpful, but it's okay if you don't remember. Any questions? All right, let's do a couple of examples. Page 139, examples. Examples. 139. I like teaching y'all math.
Thank you.
Y'all put me in a good mood.
Thank you. Thank you.
Yes, Kelly, get back to work. All right. 139, number 2. Number 2, it says list the first 4 multiples of each number. All right, 9. Joseph, what are the first 4 multiples of 9?
9, 18, 27, 36.
Very good. And you can stop because they asked for the first 4. Any questions? Tanner, questions? You sure? Well, let's move on. Let's look at 8. Is the first number a factor of the second? Okay, so 8 says 7, 44. Okay, what they are asking here is 7 a factor of 44? Meaning, can 7 go into 44 evenly with no remainders? And Talia is shaking her head like this. So you think it's no?
No,
Oh, that made me
7 times 6
dizzy.
is 42.
That's right. And 7 times 7 is 49. So the answer is no.
Nope.
So this, you can, if you know your divisibility rules, which really won't help you on 7, but if you know your divisibility rules, that's where that would be helpful. But if you're like, man, I don't remember, all you do is go over here. See that right there? See Tanner? And you try to divide 7 into that evenly. If you can't and you get a remainder, then it's a big old no.
And it's 6 remainder too.
All right, let's look at 10. Kelly, you can watch the video later, girlfriend.
No, it's just hard because like I'm literally looking back at this problem hard.
Okay, well, you know. Okay. Tanner, is 5 a factor of 75? Can
Yes.
5 go into 75 evenly? And she says yes. Yes, yes.
Yes.
So do we understand this? Let's look at 14. Is 9 a factor of 217? Ooh.
We could do division.
Okay, Talia wants to try.
Okay, hang on.
You can do division over here, right? 217 divisible by, or divided by 9.
It's not because you have a remainder of 1 if you do it.
Okay, so it's a no.
It's
Or, look at this,
24
Tanner. What's the rule for 9? We add our digits.
Oh yeah.
7 plus 1 is 8. 8 plus 2 is 10. Can 9 go into 10 evenly? It's a no. So there's that's why I purposely did that one. That's what I'm talking about. If you can just do plain old division to find out, or you can remember your rule.
I personally find that easier to remember because we've already learned that.
Right. But either way. Okay. It says, write which of the following numbers are factors of the given number. Blah, 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 blah. Do you see that in your directions?
I don't know what page we're on.
Girlfriend? Kelly!
Yeah, I'm already done.
Oh, okay, well, turn in. Well,
How did you know that?
because she's paying attention to us and not taking her test. Okay. So, 16. Listen again. look at the directions. Write which of the following numbers are factors of the given number. So they give you 2, 3, 4, 5, 6, 8, 9, 10, or none. Do you see that in the directions? Okay, so for 16, the number is 3,620. What you're supposed to do is write down which of the numbers in the directions that can go into it evenly. So, Joseph, can you think of one that can go into this number evenly?
2.
2 is correct because it ends in 0 or it's even. Or he was over here and divided it all out. Just turn the box. Okay. Or you can just look at it and say, oh, it's even. Or, you know.
Get you 1,800.
So 2 goes into it. Is there another one, boys and girls?
Yeah.
Okay, Italia. Which one?
5.
5 can go into it. Because by rule of divisibility, just get your spiral math book out. By rule of divisibility, if it ends in 0 or 5, then it's divisible by 5. Yes, ma'am?
So if they didn't give us like these numbers, we had to see like the factors of it. Would we put 1,810 as like one of the factors? Because that's times 2.
Yes, absolutely. That is a factor. Good job. Okay, what's another one? Tanner, look at the list. Can you think of another one that can go in there?
4.
Are you guessing?
Yes.
Okay, do you know what the rule of 4 is?
We didn't do that one.
Well, look. The rule
Yeah.
of 4 says it's divisible by 4 if the last 2 digits are divisible by 4. Like 524, you underline the last 2 digits. 24 is evenly divisible by 4, so this big number is divisible by 4.
I don't have those notes.
They're in your book, that chart.
So
we
We didn't write that down, but it's in your book.
That's from previous.
so
years.
yes, 4.
That's right, because look at the last 2 digits.
Oh, so it's always the last 2 digits.
Yep.
Okay.
So can 4 go into 20?
Yes.
Then it's divisible by 4. And I'll give you a hint, there's one more.
8.
Are you guessing?
Yes.
No, you're wrong.
10. Oh wait, yeah, 10.
Thank you.
Duh.
Because a number is divisible by 10 if it ends in 0. Isn't that nice?
Well, 0. What about 0?
That's not one of the choices.
Okay.
Plus that would equal 0.
1 is not one of the choices.
Okay,
0 is not divisible by 2.
don't worry about it. You can watch this
0
video.
is not divisible by anything but 0.
Okay, don't worry about it. All right, we're almost done, in fact. All right, 18. 7,139. Woo! 7,139. Can anyone think of a number that can go evenly into it? Tanner,
I'm pretty sure 3.
did you add up all the digits?
No, ma'am.
Then do it. Don't guess. There's no guessing in math.
Yes.
You go there.
No. I need my tea.
I have a similar thought too.
I need my tea for my daughter. And a cup of tea.
So it equals 20.
Can 3 go into 20?
No.
Then it's not divisible by 3. So can anyone find any number that can go into that?
No, I don't think any of them go into it.
6.
The answer is none.
Yeah, I was like, I don't think any can go into there.
That's right. Nothing.
Nope.
It's not possible.
It is possible.
All right. Let's look at number 20. Okay. It says list in order all the factors of the given number.
Can I try?
So 14, Italia.
1, 2, 7, 14.
Excellent. Excellent.
That makes sense.
Any questions so far? Joseph, do
Huh?
49.
One. So
Wait for number 18.
I'm on number 22.
So what is it saying?
When you watch the video, you will understand. Joseph, what are the factors of 49? What number, can you think of any number besides 1 and 49?
3.
3 can go into 49?
No.
Because 4 plus 9 is 13.
What is it called whenever it has a number times itself that can equal it? You do. You're a math teacher.
Don't look at your rules. Look up here. Look up here. Look at the number 49. What number times itself?
7.
Ah! 1, 7, and 49 are the only factors of 49.
Forgot all about 7.
That's okay. All right, let's look at
What is that called though? Whenever it has a number.
square,
Like what would you call 49 if 7 times 7 equals?
square root. The square root of 49 is 7.
Square root.
Okay. Look at number 26. It says, state, it's on the next page, state whether the given number is prime, composite, or neither.
Oh.
So, Tanner, is 1 prime, composite, or neither?
Neither.
She is correct. It is neither.
I don't understand that though because one it says for the rules.
The rule's 2 factors.
Yeah.
This only has 1.
Isn't it over 1? Or a number over 1?
No, yeah, but
Yeah, but like because it says it's 1 in itself if it's prime.
Two
And 1 in
factors.
itself. 1 is.
2 factors. That's only 1 factor.
But 1 in itself is 1 and 1 for 1.
That's just 1 factor. All right. 28. Raise your hand. Tie it.
Oh, I'm not even looking at it. I think-
Tanner,
No.
whoever has the answer, yell it out.
It's neither or prime.
It's prime.
I said neither. I was thinking I wasn't.
Because 19 is prime.
Sorry, I was like in another world.
30. 35. Is it prime, composite, or neither? Joseph
Composite.
is composite.
Can we just put comp?
No. No.
All right. Any questions? No questions.
No.
Okay, so we're going to stop there. No homework tonight.
Yay.
I will give tomorrow when you get in here. I will have this on the board, and you can start working on it. We'll walk around and blah 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 blah. That gives you time tonight to watch the video.
Don't worry.
And take your spiral home so you can in your book. I know it's more books and stuff, but take your book and your spiral home. Watch both videos, part 1 and part 2. Take notes so you have it in your spiral, and then you're good to go. So that's your homework. Okay? All right. Now wait. Sit down.